Hey everybody, welcome to another video. This is not going to be a complete tutorial because there's a lot of videos already about triplanar mapping, but what I did want to show you is maybe a new way to think about triplanar mapping that can help reduce the amount of texture samples that you are running on your materials. So one of the big issues with triplanar mapping is that you have to sample the same texture repeatedly from different angles in order to interpolate them together and get a composited result from all sides. And of course, texture samples aren't free, so you're doing that over and over again and incurring a cost. You do it for your diffuse, and then you do it for your normal maps, and you do it for any of your other maps. So in a lot of cases, you'll be using probably 9 texture sample nodes. And so I've got here just kind of a very typical triplanar material, rather than using the built-in world normals, just a world projected material node to show this off, right? So we have our masks, which we pull up here, will effectively, section off part of our object, and then we have our world coordinates, right? And you combine them together in order to sample, right? So first you sample, oops, didn't want to do that. First you sample the texture, and then you interpolate it with a texture that's sampled from a different direction in order to get a smooth transition, and then you do it a third time. Normal maps are a little more complicated. You still sample them 3 times, but when you're doing world-aligned textures, but you're projecting a tangent space normal on it, you need to do additional transformations, which is what all of this business is. This is just a bog standard normal transformation that you would find in any triplanar video that covers that. So not really worth getting into the details there. There are other videos to watch if that's what you're trying to do. But what I wanted to talk about is this material. So I have 2 spheres here. This one right here is using this material, and this one right here is using the other material that I just showed you. And I'd be willing to bet that, especially over YouTube, but even honestly right here in person, most people would not be able to tell the difference between these at all. The difference is that this is triplanar mapping, seamless triplanar mapping, happening with just 1 texture sample per texture. And the way that we are accomplishing that is with a temporal dithering effect. So if you were to get really close to this and look really carefully, you may maybe be able to make it out. It's a lot easier if I go ahead and turn off real time on this material and I zoom way in. Maybe some of you are starting to be able to see. I don't know if this is going to show up on YouTube at all, but you can see here without the temporal anti-aliasing and the dithering happening in real time. This transition is kind of a speckle, and this is as opposed to a hard seam, right? If I go into the parameters here and I go and set this up to 150, we'll say, right? So typically when you, in fact, even this is softer. So, typically you have a very harsh seam, in fact, even harsher than this because it's still dithering it to some extent. But, so I've just got this set to a soft level. So it's sampling different textures and it's dithering it out to smooth the transition. And so if somebody is able to see this dithering effect, watch what happens when I enable real time. And it's gone. Right? Just disappears, completely seamless. So what exactly is going on here? This is very much the same kind of technique, right? So I'm just setting up a triplanar mask. I'm just using the R and the B here because technically you don't really need all three, because if you have two, then the difference between the two is the third. So we have the parameter here that controls the sharpness of the transition between the different planes, right? So very typical stuff. And then here's where the magic happens. And I just want a quick side note too. The first time I saw this technique was in a GDC talk from Far Cry 5 from Ubisoft, which talks about using stochastic noise and hashed alpha testing to dither their triplanar mapping. But I think that I've got results that look a little better than what was described in that paper, but I'll link it in the description. I think the key here is that temporal anti-aliasing. I'm also using a slightly modified version of the Dither temporal AA. The stock one works fine, but the difference here is I am just sampling a blue noise instead of just regular noise, and I also have that blue noise animated, so it's essentially a flip book that constantly changes, which gets rid of kind of you could call it an orange peel effect, where the noise on the screen is persistent in screen space, and instead it's constantly flickering each frame, which the alternative is that you get like a teeny bit of flicker, and if you look really closely, you may be able to see it. In fact, if I were to lower the screen percentage significantly here, even then it's still not really visible. All right, well, in any case, in person, you maybe could see a teeny bit of like dancing pixels from the animated flipbook, but in my opinion, it's a lesser evil than kind of the static screen space noise. But what's happening here is I'm just selectively applying the dithering to the bands where the transition occur. So, right, we have our mask, just like before. So if I pull this up, we've got the areas that that plane is going to operate on. I'm inverting that and then multiplying it by itself, which gives us a gradient where I potentially want that dithering to apply. Then I am actually applying the dithering to that area before adding it back to itself to bring back the original values, and then finally using a round to make it so that it's either true or false, right? I just want one bit, and the reason for that is because when we are sampling our UVs, we don't want to actually blend between different values, right? I either want it to be on a particular plane, or I want it to be off that plane and sampling a different one. You really can't have two different planes sampling at the same time when you're doing this, because it can't interpolate between them. It's dithering, in order to achieve the same effect. And so then we take our planes and construct our UVs, right? So here is the blended UVs, and you can see here probably much easier. Yeah, this actually shows it a lot better, the animated noise. And I can actually turn that off. So you can kind of see how it's dancing. If you were using the stock effect, it would have a screen space. look to it. But ultimately, you can see better how this is working, I think, in this view, right? As it transitions between the different samples. So this is, 100% sampling the top. This is 100% sampling the side, and then each step in between, it's mixing those samples in between using that dithering effect. So what about the DDX and DDY? This is really important when you are dealing with MIP maps. Essentially, MIPs are automatically computed by calculating the distance between pixels to try to determine what MIP level should be used. And if you are using something that's altering the way that your coordinates are being calculated, like lerping between two completely separate coordinate systems, it's just going to get super blurry. And in fact, if I just were to turn this off for a second, you can see how this looks, right? It just gets blurry, and that's because it's using a very low MIP level because it thinks that the texture is really far away from the screen because of the distance between the pixels. So you have to explicitly use your MIPs here with these derivatives in order to get the correct result. Texture samples broken, so we're just going to grab another one. But in any case, that's a really critical part of the process, or else your results are just not going to look good at all. And as far as the normal map goes, this part is mostly the same as your traditional setup. You transform your world space normals and get them over into tangent space and do some swizzling, right? So this is all standard stuff, but the difference is just that there's only one sample, right? If I go over here, you can see I had to sample each texture and then separately combine them, whereas here it is all done with one, and that can be reused again and again because it's all under one sampler. So it's the same basic concept. It does need a little bit of reworking, so I'll just show that here. And this part is the mask, right? So if I just were to preview this is the exact same thing, right? So this is masking out which normal map is showing up. This is really important because you don't want any part of the normal map to be added together, right? So it's, in this case, it's either the top normal or the side normal. It can't have any pixels that are sharing normals together, or else they'll look wrong. And so this is the same concept as what's happening here, right? Here I'm multiplying these against the masks. So if I were to look at this, we can see this is the result, right? But it's a smooth blend, whereas in this one, we get the exact same idea here, but again, it's a dithered blend. So that's all taken and output to the normals. So that's pretty much all there is to it. I know I kind of glossed over a lot here, but again, you should be really familiar with triplanar mapping as a concept before attempting to do this. And I don't want to just retread a bunch of ground that other people already have to show this off. Another really interesting thing about this technique is not only does it work for cases like this really well, for blending together different UV coordinates of the same texture, you can actually use it to blend together samples of arrays, right? So over here, I have a cube that is sampling a texture array which I will show you here, right? So we have a texture array, and this is just a couple of things. When you create a texture array like this, you need to set its MIP generation, compression type, and so on manually. So that way, if you're using normal maps and diffuse maps, they are all correct. You can't just create it and throw them in there. But if we go back to this, what's happening is this append, this is being dictated by just some logic here to take a gradient, right? So I take a gradient and I break it up into quadrants, which I need to grab a rack to see. All right, so here's section 1, 2, 3, 4, and that's going into the append with the texture coordinates and giving us the final output. And this is using the exact same methodology here, the same concept. So if I turn off real time, again, we can see the dithering creating the blend from a single sample. If I were to turn this here, right, this is what you would normally get if you try to sample in this way on an array, right? You get a sharp blend, and that's okay for some things. But if you're trying to make a terrain, for example, and you want your stone to seamlessly blend with your rock, you need to have a way to do that. And this dithering will allow us to do that. And again, you can watch here and see, it's very clearly dithered. And it holds up okay from a distance. I wouldn't ship something like that, but it's okay. But once we throw on those temporal effects, it becomes totally seamless. In areas of extremely high contrast, like this wood versus this rock, it's not really a very realistic scenario, but there is probably the most obvious issues with it. But the point that I'm trying to make is that you could have a complete terrain system, right, where all your cliff faces and stuff are using triplanar mapping, and all of your textures are switching between the different types. And you could do that with a single diffuse texture sampler with with an array, right? If we go back to this triplanar setup here, right, this could be a texture array, and I could have all of my terrain textures stored in that, and just sample a virtual texture, runtime virtual texture, to tell me which which index on my array I should be using, and then that's it. It's all operating off of just one one texture for the diffuse, and one sample against a runtime virtual texture, and then you can reuse that for all of your different mappings, and you could get 3 texture samples total. Using a noise-based dither temporal anti-aliasing does also include a texture sample, because that noise is the texture, right? So using that will increase your texture samples by 1, but it's just a very small, low resolution thing, so it's not really a big deal. And yeah, I mean, that's really all there is to it. Hopefully this is something that you find interesting or useful, and you can take advantage of it. I think temporal anti-aliasing gets a bad rap for causing some visual issues, and that's certainly true, but it can also be used to great effect to do this sort of thing. Speaking of visual issues, let's talk a little bit about some of the downsides. If I just go ahead and let's just grab maybe a sphere here, and we look at this. As I move this back and forth, you may see a bit of ghosting. I don't know if this is going to show up a lot, but in areas of very high contrast, not only is the effect more obvious, but you will see ghosting effects like that. Right? So like it doesn't really show up all that much in every area, but it is something to think about. This is not really an issue with the triplanar mapping because there's not really anywhere near as much contrast. Right? You can get it to happen, but it's not visible to my eye, generally speaking, and it's probably especially not visible over YouTube compression. That's really the biggest downside. Outside of that, if we go over to our project settings here and we go to anti-aliasing, this effect works best with temporal super resolution. It works okay with temporal anti-aliasing, very similar result. Definitely not a problem by any means, but I did find in my experimenting that the ghosting was maybe a little worse with temporal anti-aliasing, but it is important that you use temporal anti-aliasing, right? If I turn off anti-aliasing altogether, the dithering effect becomes super obvious. But this could potentially be something that makes a triplanar mapping technique viable on mobile, right? Maybe if you can't afford texture sampling, even without temporal anti-aliasing, that might be an acceptable look for mobile devices and VR. So, yeah, that's really about all I wanted to say. If you have any questions about the technique, throw them down in the comments. And I hope you have a fantastic day.